So yeah, envelope and R value. A lot of what I'm going to talk about here tonight is preparing you for these conversations when people hit you with the question of R value, and steering your knowledge and being able to discuss it in a way that when you are talking to the larger construction industry or someone in code enforcement, that you don't show yourself to be uneducated or misinformed, I guess is a better way to say that, when you're talking about these things. So first and foremost, the question we always get is what is the R value of hempcrete, right? And that again, you guys have heard me talk about. You've probably seen my report here, the C518 test. That comes down to a matter of FTC compliance. In order for you as a producer, especially in our case of an insulation system and a supplier of the raw materials for it, you are not allowed to discuss R value if you've not done the appropriate testing. It's a fine. It's a real fine. It's like a big fine. And you have to be prepared to defend that. And the first and most basic test for that of many is this C518 thermal test, where basically it's a hot plate test. You take a sample of the material, you put it in an apparatus that heats up on the bottom and then measures the transfer of that energy through the material, right? So R value, although it is the one thing that you're going to be held to, is not the full picture when it comes to hempcrete, right? The PHRC report that you guys have probably also heard me mention and talk about, which is available now on the PHRC website, they go into detail on how they verified the performance of the material on site in a finished installation, that goes above and beyond this basic C518 thermal report lab test, basically. So in that report, you'll see that what they actually did, and this is a method that Dr. Mamari and his team,
Hey, Cameron, you froze there. I don't know. Can everyone else hear?
Yeah, he froze for me too. I was just about to break in. And Cameron, I'm not sure if you can hear us, but we'll give it a second to catch up. And then I'll point out that Gene is putting that in the chat so that you can click on it and make your downloads there on the chat. And Cameron is still frozen in some face pause, and we'll give him a second to
well,
catch
what's
back
the
up.
R value? Okay.
Yep. Okay, there you are, Cameron. You broke up for about a minute, and then,
oh shoot, I'm sorry, guys.
Yeah. So
where did I cut out, Ray?
You were revealing the secret of life, and it was the.
You were talking about Dr. Mamari and introducing the report, and we've got the report in the chat, so people can look at it.
Yep, and I can bring it up and we can look through it again. I know I did that already once, but again, there's a method that Dr. Mamari and his team devised for assessing the R value in situ on a finished build, right? And it's basically that same hot plate test, but it's a series of sensors that are arranged on the inside and the outside of the wall that measure the performance of that material in situ, which is going to be more accurate than even the stated R value of those various materials via their respective C518 tests. So it's really important to understand, and I mentioned it before, that that was a 10-inch assembly that we did for Project PA Hemp Home, and the way that it tested out, and I think I mentioned this in another class, was to show that 10-inch assembly was actually performing at R17, which was kind of a holy shit moment for me and John Sara at Parsons, because we thought, hey, we put hempcrete in the wall. It's supposed to be 2 or 2.2 per inch. Why did it only register R17? Well, again, that is because, the testing that they do in field in situ is going to be more accurate. It's going to take into account, the function of that wall as it exists, right? So a basic R value test in a laboratory environment, especially for a contemporary insulation material like pink insulation or rigid foam or anything, that test is kind of skewed. The one in the lab is not going to necessarily be representative, and the reasons why relate back to the framing detail in reality. Skipping ahead here to thermal bridging, the cold bridges that are represented by the denser materials in your wall, the framing, that framing is not very insulative. It's very dense, meaning it will transfer that hot and cold energy much quicker than what might be represented again in that lab test. So John Sara and I looked at Dr. Mamari and we said, well, what went wrong? And he said, no, you don't understand. That's good. He said, a typical R20 pink insulation insulated wall with that same test that Dr. Mamari does usually comes back somewhere around R7 or R9, which is terrifying. But again, it's a measurement of how that wall assembly is functioning in the field. And in the case of a cavity insulation like pink insulation that's positioned in between stud work in a wall, what you're not getting out of that lab test is the reality that everywhere you have a stud that is touching an interior and an exterior finish. In the case of a contemporary home, that's the plywood and the vinyl siding on one side and the drywall on the other. That's actually a cold bridge, meaning it's transferring hot and cold energy much faster than the insulation itself. So skipping back to that thermal inertia point, the term mass is thrown around quite a bit when we're talking about hempcrete. And yes, it is a massive material. But the real property that we need to focus on is the thermal inertia, which is a measure of how slow, in reality, the material hempcrete is to react to and to absorb a hot or a cold energy. And that's part of what makes it a dynamic insulation material. So yes, our PA Hemp Home project, I think there was one of you in the group actually who I wrote an email to this after the fact. Yes, it tested at R17, but the other half of that research, and the more important half of that research, was the sensor array that they left in place in the house to monitor interior temperature, humidity, and exterior temperature. And what they found was, versus modeling of contemporary construction, that hempcrete home, that Project PA Hemp Home, is actually outperforming the modeling by 30 to 70%. So, the reality is that the R value is not an accurate portrayal of how performant a material like hempcrete is. So again, arming you all for the discussions that you're inevitably going to have with clients, with, prospective builders, the general contractors you're going to run into, understanding that R value is not the full picture is really important when you're talking about these things. So the point is, an R20 insulated pink insulation wall versus an R20 insulated 10-inch thick hempcrete wall, the hempcrete is going to outperform that pink insulation dramatically, and it comes down to the thermal inertia of the material, not the mass, not the R value. It's that thermal inertia and the material's ability to resist fast changes, right? So this is another way that I like to portray it for people when I'm having this discussion, is that the R value is a measure basically of how well does an insulation material reflect hot and cold energy, and to compare the R value for a batt rigid foam insulation to a material like hempcrete, it is not the full picture. So, that's critical to understand when you're engaging in these conversations. And the way that boils down is that, in a given area, you're subject to proving that you can hit the stated R value that's required in a given area for the thickness of wall, right? So in Pennsylvania and in much of the Northeast, actually, I would say from Virginia all the way up through New York, the wall value requirement for an exterior wall is R20, as demonstrated by a C518 test, not as demonstrated by actual in-field performance. So, that is what we base our thickness calculation on, is how are we hitting and how are we making that requirement from the township or that municipality for that given area, and what they want out of an R value, knowing and resting assured that, yes, we are doing as much hempcrete as is required to hit that R20, but resting assured knowing that the finished product is going to dramatically outperform the calculation that went into assuming that they needed R20 for an exterior wall here in Pennsylvania, if that makes sense. So,
Cameron,
it's really critical to have an understanding of that. And then also on the other side of that, to know that, there have been certain scenarios where the client says, oh, I'd really like to outperform, that stated R value. Well, every inch of additional material that you add to a hempcrete project has a real dollar value attached to it. So my recommendation always for clients is, let's do the amount of hempcrete that we can defend that will hit the stated R value for that given area. And we will know that, based on the results from this PHRC test, basically, that we're going to outperform that. Now, when you get into here, and we're going to talk a little bit about, high performance building and passive house here in the next couple slides, often the R value requirements get way out of hand really quickly. Some places to hit, passive house performance, you need R60 in an exterior wall. Now, there is no scenario where doing 30 inches of hempcrete, whether it's spray applied or hand cast, is going to be, a valid and a worthwhile endeavor. And a lot of this comes back to, roof R value requirements are often higher than exterior walls. And here in the Northeast, it is, an R30 plus for a roof assembly. And that gets to be a major engineering challenge, especially in the Northeast, when you have to consider things like snow load, or, even the Midwest, Gene, Colorado. You have the potential for, anywhere from 1 to 3 feet of wet snow to be dumped on a roof at any given time. And then you've also got to plan for the engineering load of the weight of the hempcrete in that roof. It really pushes the project into a whole new realm of cost when you have to do, or when you're trying to do hempcrete in a roof assembly. So, most of our projects, almost all of them, other than a handful of small, ADU type projects, we've done something other than hempcrete in the roof. And that's not to discourage any of you from doing hempcrete in the roof. And that's a good segue here into the monolithic envelope discussion. It is valid to want to have hempcrete in the exterior walls and in the roof, all connected, one piece, an uninterrupted monolithic casting of insulation. That's valid. We've all seen, images from, the UK in particular, where, most all of the UK builders, they do hempcrete in the roof. But the reality is, we need more testing and more engagement with universities and researchers to prove that we don't need these ridiculous thicknesses of hempcrete in a roof assembly to hit, the performance category or target that they want you to hit when it comes to designing an envelope. So right now, we're tied to that. Again, ball and chain, anchored. We're anchored to this R value thing. But the reality is that it's not a good representation of the material or how it functions, right? So,
Yo, Cameron.
Yes.
So
Angel.
question on that, my friend. So you were saying about the hempcrete in the roof. I know recently when I worked with Kansas State University, we utilized hemp wool, and I know that there's some people that are out there that mix the two contents together. What
Right.
would that? What is your opinion on that? On doing like say 3 inches of hempcrete and then doing the rest with hemp wool, for that thermal envelope? Like, what's your opinion on all that?
Super valid. I like it. And the reason why I like it, especially if you position the hempcrete to the inside of the space, is that again, that thermal inertia aspect of the hempcrete, having that to the inside of the space is ideal. You wouldn't necessarily want to do it the other way where you have hempcrete on the outside and then, a bat insulation, whether it's hemp wool or anything else on the inside, because that layer of hempcrete, whether it's 3 or 4 inches, is going to function as a battery almost, right? Where once you heat up or cool down that space, you're taking advantage of having the hempcrete in the roof in terms of the storage capacity, the thermal storage or battery effect, and then you're isolating that mass of hempcrete, that thinner mass of hempcrete, with a higher R value, lower thermal inertia material like a bat or a rigid or a foam, so that hempcrete wad in the roof is not losing energy to the outside, right? So I think that's really valid, and especially where you are, Angel, none of that shit I just said about snow load is applicable. Or excuse me, no, you're in Kansas. I guess you guys do get snow, but
Yeah, we just got hit. We just got hit with a snowstorm like this last
right.
week, and that's where I was really thinking
Yeah.
in the last couple of weeks. I'm like, well, if only we just utilize hempcrete and hemp wool for the roof, then we can at least solidify some of the thermal and some of that cold that's coming in through the roof and leaking in through there. But I wanted to double check with you
But
guys on that because
you're not going through the exercise or the cost of having to do the entire roof assembly with hempcrete. I think it's valid, Angel. And again, I think that, the way that I look at a roof system is, that's where you want the super high reflectivity, R value materials. In a lot of cases for our projects, it's been something like dense packed cellulose. I have a picture of that here later. Or bats. I've had people do the sheep's wool. The Havelock product is really cool. Unfortunately, it's imported from New Zealand, obviously, but that's a really great natural insulation. But your roof is obviously where all of that heat energy is trying to escape, and you want to keep it in the space so that the hempcrete has an opportunity to absorb it and then slowly dissipate it, right? So the way that I think about it, it's not sacrificing performance to have a higher R value and a thinner profile in the ceiling cavity, and leaving the thermal battery effect to the exterior walls where you have your hempcrete, right? So literally every one of these residential homes that we've done, and even you guys, the Hillside project, they're not doing hempcrete. This is the big panel project in Newburyport. They're not doing hempcrete in the ceiling on that. It's going to be a dense packed cellulose, for that same reason that I just described. But yeah, combinations of materials though too, Angel, it's incredible what you can do. And Hempitecture has a new product that's a rigid continuous exterior insulation board, right? It's a thin, I'd say like a 2-inch panel that they're making that's much denser and more rigid than the hemp wool. But the idea is that you could attach that to the exterior of the studs, like here in this detail. Let's imagine that this third layer here, which is shown as it's a building wrap, but it's shown kind of thick, so it works for the purpose of what I'm trying to say here. Imagine that layer right there being that Hempitecture. That Hempitecture, what are they calling it? Hemp panel or whatever they called it. Having a layer right there of a rigid continuous exterior insulation, whether it's the hemp wool product or a wood fiber board, or even even the rock wool product that's like that, putting that on the outside and gaining an R10 in a 2-inch package. I think the hemp wool product is like R7 for a 2-inch package. You can eliminate then that much hempcrete. In that case, that's almost 4 inches of hempcrete. If I'm getting an R10 out of a rigid continuous exterior insulation that's been applied to the outside of the building, I then need less hempcrete on the inside to hit that R value requirement, right? So in the same vein of your question there, Angel, you can apply that thinking to the entire envelope and say, hempcrete's expensive. That's why, people are balking at these projects because they're interested. They ask how much it's going to cost. They throw up in their mouth a little bit and then they never call you back, right? How do we make it so that hempcrete fits? And this is a tangent. You got me wound up now, Angel. How do we make it so hempcrete fits more harmoniously into, contemporary construction techniques? Well, one way would be to limit the amount of the hempcrete that you actually need in the space to get a really high performance envelope. So if you're to use an R7 product here, your wall value requirement is R20. You've got R7 in that panel right now. All of a sudden, all you need on the inside is 7 inches of hempcrete to hit your R20. So you've gone from needing 10 inches of hempcrete down to 7. And I can tell you from the estimates that I've done that carves off a decent amount of the cost. And again, you're using that high R value, high reflectivity, thermal reflectivity material on the outside as a way to help insulate this hempcrete on the inside from losing energy out this way, right? So it's super valid, you guys, and the combination of these materials has been part of our success too. I've sprayed directly against rigid rock wool. We came up with a detail that we executed on the Lower Sioux project that you guys saw, where we had that Mento building wrap pre-installed and then these furring strips for the siding pre-installed, and we actually sprayed directly against it. And what did that do? It eliminated us having to do that painful forming process. We literally did no forming for the Lower Sioux project. We had that Mento attached here. Exactly this detail, you guys. This is from the Parsons write-up on Project PA Hemp Home, you guys. This is their detail and their drawing of how we insulated and installed the hempcrete on the Project PA Hemp Home. And again, it had that Mento fabric. Had I known back then, you guys, that we could do that we could spray directly against it, I would have had those guys put the Mento fabric on, put the furring strips on, and then I would have sprayed directly against it. Now, mind you, caveat there, I am confident doing that with the spray applied method because of the mixture that we're using being a much lower binder to herd ratio and much less water per volume per batch than a normal cast in place mix. You have to be very careful. And in fact, we call it out in the IRC index that you are not supposed to use permanent shuttering or permanent formwork of any kind, whether it's this membrane or what have you. But in the case of the spray application system, and we did do some independent verification of this, it worked fine and it was able to dry out to the backside. So typically, you would not want to have a permanent formwork if you're doing cast in place. We're getting away with it with the spray applied because we have so much less water, and we now have several installations where we've done this against a permanent formwork and we had no moisture issues. I think that there is a potential that could be true for cast in place as well, but you got to be much more hyper vigilant. And again, if your code enforcement official calls you out on that, you're not going to be allowed to do it. So that's something though that for my personal company, we are going to be independently testing and verifying that functions properly. From what we've seen in the field, Danny and the Lower Sioux are in a special place on their reservation where nobody can tell them what not to do. So they were willing to try it, but I had already done a mock-up sample wall where we did try that. So anyway, great question, Angel. And I think, there's a whole world out there of finding material combinations that make it so that you're not having to do as much hempcrete, therefore making the overall cost of the project more palatable while still having the interior air quality benefits and the livability benefits and the performance benefits of having hempcrete. You know, how do we find ways to make this really harmonious with what's happening in construction in general, right? And another segue here into my next slide, talking about air sealing. For those of you that are in the trade or in any trade, construction wise, I'm sure you've heard of and have a familiarity with passive house, right? Which is, you know, basically an energy performance metric where you are demonstrating that, you know, by air sealing and making sure that you have zero air leakage, that you're building a more energy efficient wall assembly. Now, traditional passive house wall assemblies get to be very complicated. They're very expensive and very complex. And here's another tool for you all to arm yourselves when someone has this question for you about R value and, oh my God, it's such a thick wall. Why does it have to be so thick? Well, the reality is, if you were to build to the performance standard of hempcrete, which you can do with contemporary materials, that construction detail is going to be every bit as expensive as doing hempcrete. And the reality and the point that I'm making here is that hempcrete actually simplifies the principles of passive house, eliminating complicated, you know, air sealing and drainage layers, you know, for moisture that gets trapped in between the wall. With passive house, you're really relying on, you know, a shit sandwich of different layers of membranes and drainage planes and all this stuff to hit that performance target. Whereas you can use hempcrete, you know, a sustainable, biogenic, natural insulation to achieve that same performance in a much simpler wall detail. Okay, so you're eliminating a lot of those different layers that you normally have to have. And any of you that have ever engaged in a passive house project or a client wanted you to design the passive house, you know exactly what I'm talking about. It's a nightmare. And the passive house specific architects and designers that I've spoken to, they've all echoed that. You know, that was the first thing they said was, wow, if this stuff does what you say it does, then it really dramatically simplifies what I'm trying to do with passive house, right? So again, passive house comes down to air sealing. And we have on many of our projects, especially the more high-end projects and the ones that are in states like Massachusetts, where there are actual tangible, you know, monetary incentives to hit passive house performance. That's not true in every state. Massachusetts is one of the few where they really do encourage people to hit these performance targets. And there are subsidies and money that you can apply for. David and the Hillside Center, for example, you know, they get a nice big wet check for having demonstrated that they're hitting passive house. Again, that's specific to Massachusetts, but you know, air sealing around penetrations is the game with passive house. You have to make sure that every outlet, every switch box, every, you know, service penetration, every window, every door opening has to be air sealed, and you have to connect those air sealing layers around those openings back into, in this case, what is a plaster finish, right? So the meditation with hempcrete is airtight but vapor open, right?